plus or minus two things, okay, two pieces of an expression. So that would be a term if I had on top plus 1, that would be 2 terms on top. But there's nothing like that. So this is just single terms. When you have single terms on both the top and the bottom, what you want to think about doing is you just want to think about dividing by the greatest common factor. So dividing by the highest thing you can possibly divide by, and to get rid of the most x's that you possibly can as well. Okay, so you should pay attention to this, because if you don't know how to do this today, good luck with the rest of this unit. Okay, this is like going to be brutal, because the rest of the unit requires you to do this. So we really have to get the hang of it early. So please pay attention and write it down. Okay? So here what I should be doing is I should be looking at 24 and 18 and thinking, what is the highest number that I can divide both 24 and 18 by? 6. So I will divide both of them by 6. And I have 2 A's on top and 3 on the bottom. It is really important that you understand how this works, is that you can divide by the lower number. Okay, so if you have 2 on the top and 3 on the bottom, I can divide by 2 A's, or A squared. Okay, so it's always the lower number, because you can't take away more than is there. That's the important thing there. So I can't take away more than one of them has. So I can't take off A cubed, because the top doesn't even have an A cubed. Okay, so I'm going to divide both of them by 6A squared. So negative 24 divided by 6 is what? Negative 4. What's A squared divided by A squared? Is it A? No. They cancel off. A squared divided by A squared is just 1. Okay, so there is no A there anymore. And on the bottom, I have 18 divided by 6, which is 3A. So when you're dividing with the variables, you should be thinking of it as a subtraction. That's something you learned in grade 9. Dividing powers, you subtract the exponents. So I had 3 minus 2, which is 1A left over. Now you should also always state the non-permissibles. Okay, and the non-permissible, I mean, technically here it doesn't really matter where you look, but generally speaking, we look at the original expression, and you look at the bottom. So 18A cubed, does anyone have an idea of what value could I put into A so that 18A cubed was 0? 0. So it's a 0. Okay, basically, if there's no plus or minus, but there is an x down there, it's going to be 0. Okay, or an A in this case. It's not x, but same deal. So this is that expression simplified. So it's an equivalent expression, and it's also in its simplest form, because I can't divide by anything else. Okay, now one way to check these out, if you want, if you're like unsure if you did it right and you want to check them out, is you can always type into your calculator the original expression with some number plugged into A, so like 1 or 2 or 3, I don't know, an easy number. And then type in the bottom expression, your answer, with the same number plugged in. You should get the same answer. So you can just always check your answers that way. So if I plugged in 1, I would get negative 4 over 3. And if I plugged in 1 to the bottom there, I would also get negative 4 over 3. So I would know I'd done it right. And I wouldn't do it by hand. I would just type it into a calculator. Okay? So that's how that one can be done. Okay, so now here, simplify the following. This one's obviously harder. Now, as soon as you have more than one term, I mean, you can actually do this. There's more than one way. I guess I'll show you both ways. You can actually do this just by dividing by a common term, just making sure that each of them gets divided. That's a completely possible way to do this. So there's 2 ways. So I'll just say the first way is dividing. And the second way is factoring. And they're equally good. I mean, if I'm doing it myself, to be honest, I'm factoring, but I don't think there's anything wrong with just dividing by something if you're capable of it. So as long as you understand that everything has to get divided by the same. So what I see a lot of students do this, is they look at this, especially students who've seen it before. So I would expect to see this from 20-1 students. I would expect to see a lot of people doing things like this. Oh, okay, they look at it and they're like, oh, 15x cubed is on top and on the bottom, so I can cancel it off. I see a lot of that from people who've done this unit before. That's not correct. If you wanted to divide by 15x cubed, you would have to divide everything by 15x cubed. So instead, you have to look at all three terms and think, what can they all be divided by? So what could 15x cubed and 5x both be divided by? 5x. So if I divide by 5x on both the top and on the bottom, always remember it has to be both. Okay, I get 15 divided by 5 is 3x squared, because it was a cube and a 1. Now 5x divided by 5x, what's that? Negative 1. And on the bottom, what will I have? 3x squared. Okay? And here the non-permissible value would be 0 again, because it's just 15x cubed. The only thing that could be plugged into there is 0. Now the other way, the way that generally speaking you'd be taught this, is to factor something out of the top. So on the top there, I would factor out, because it's a common factor, I would factor out 5x. Oops. Okay, and then inside the brackets, I would have 3x squared minus 1, okay, over 15x cubed. But then it does become the same process where you are dividing by 5x. I like it like this personally, because what I personally do when I do this, I don't actually write I'm dividing by 5x. What I always do is I think, okay, I'm going to take off 1x from the top, and I'll take off 1 from the bottom. So now there's 2 left. And I'll divide by 5 on the top, so that 5 would be gone. And I'll divide by 5 on the bottom, so that'll be a 3. And then I end up with this answer, 3x squared minus 1 over 3x squared. You still get the same answer either way. And actually, you're doing exactly the same thing. You're still just dividing everything by 5x. It's just written out differently. So whichever way you prefer. I actually think the first way, dividing, is probably easier, because as long as you can spot that common thing that you're supposed to divide by. Yeah, it's just adding an extra step in some ways. So, but there will be problems where you have to factor. There's just not going to be any other way to do it. So we'll see some of those as well, just so you can kind of get an idea of it. I think here, though, it's very easy to just divide by something that you can spot. Okay, so either way you get the same answer, though. Okay, so this is an example where you could just divide, I guess, but factoring, I think, kind of ends up being easier. But let's check. Okay, so if I was factoring here, let's just factor first so you can kind of see it, and then I'll try it the other way as well. 6 and 8. What is something that goes into both 6 and 8? 2. And there's m squared and m, so it's going to be 2m. Now, to multiply 2m by something, I need to multiply 2m by 3m to get 6m squared. What do I need to multiply it by to get negative 8m? 4. So it's minus 4. And on the bottom, I have 3m cubed and 4m squared. So what can I factor out of there? M squared. And in the brackets, it'll just be 3m minus 4. So this is a situation where it's actually much better to factor, and we'll see why in a minute. But here, once you have common factors on the top and the bottom, so factors, the word factor, I'm sure many people in here don't know what it means. It means multiply. So when we're saying factors, it's things that are multiplying together. So up top, 2m is multiplying by 3m minus 4. So they're factors of each other. Okay, and on the bottom, I have m squared is multiplying by 3m minus 4. So those are factors. If you have a common factor, so something multiplying on the top and the bottom, you can cancel it off. Because 3m minus 4 divided by 3m minus 4 is 1. That's the reason you can do it. It's because we're dividing them by each other and getting 1. So here, since these are exactly the same, I can cancel them off. Okay? What else could I cancel? One of the m's. So there's one m on top, there's two on the bottom. So I can cancel off one of them. So if I cancel one from the top, I also have to cancel one from the bottom. And I'm left with just 2 on top and m on the bottom. Okay, and that's the way you should do this question. If you try to do it another way, like you could say, oh, okay, I can see I'm gonna be able to divide by m. Like you could have seen that and said, they each have an m, so I'm gonna divide by m. But you wouldn't get this answer, right? All you would get is you'd get 6m minus 8 over 3m squared minus 4, and you still wouldn't have 4m. You wouldn't have the answer. You'd still have to factor, right, to actually get the total simplified version. So sometimes factoring is really necessary, which is why I guess I always factor, is just because I know it's often going to be necessary, and I know it's going to be the way to do it, so I just always do it. But there are situations where you don't have to. This is not one of them, though. This is a you must factor situation. So generally speaking, if there's more than one term, you factor. Now, the non-permissible values, they don't come from the last step. They come from the step where you factor. So you look at the step where you'd factor for your non-permissibles. So I had m squared, and I had 3m minus 4. So you should have two non-permissibles, one for m squared and one for 3m minus 4. What would the non-permissible for m squared be? 0. And for 3m minus 4, does anyone have an idea? 4/3. It is 4/3. So just so that people understand, if they think that that was just magic, you take the 3m minus 4 and you set it equal to 0. You would add 4 to both sides, so you get 3m equals 4, and then you would divide by 3, so you get 4/3. Okay? It is something you can do in your